Hi there, my name's Matthew Waring. I've recently needed to use this particular Objective-C plugin or whatever, CocoaPod, open source GitHub project for attributed labels. So obviously you can see it's TTT attributed label, and I want to use this in my Xamarin project. So I'm pretty new to binding the Xamarin projects. I've just gone through a bit of pain for a few hours in learning some of the ropes. By no means anything more than a beginner, but I thought I'd record this video because I think it'd be very helpful to see some of the mistakes. I'll redo the mistakes that I made because I think they're a good learning exercise, and obviously how I overcame them in more of a summary fashion, and hopefully someone can gain some benefit from this. You can see that a good starting point, obviously, for learning how to bind an Objective-C library is the Xamarin documentation. I think it's very good. There's some things that are assumed in there that can be quite painful in the usage of Xcode, which we'll go through. I'll be splitting the videos up into a couple of minutes each one so that I can chop and change and move things around. So we'll finish this introduction and then we'll get started on downloading the attributed label and make us start on creating our binding. Thank you very much. Okay, so first thing we're going to do is let's get hold of the URL so we can clone this project. I'm going to use source tree for this. You can also use the command line or wherever. Okay, so we can see that we've got that down. So we'll show that in Finder. Have a little look. So what we need in order to bind are the .h and .m files. Now you can see that there's a few other things for usage in Carthage and some other stuff. There's an example project, but as you can see straight away, we've got a H file, the M file, the implementation file, which pretty much contains everything that we want to hook into for our binding. So based on the walkthrough, the first thing that you need to create is a library that you will bind around, which is a .a file in Xcode terminology in terms of the extension. So I'm going to start an Xcode project up. I'm going to do File, New Project. We need a Cocoa Touch static library. This is the default, and it's TTT attributed label, and we'll just call it binding. We'll leave this as some default information. We'll go next. Now I've already got projects here, but we'll create a new folder. TTT attributed label binding. Create that. Press create. Okay. So first thing we get is the default project setup. So what we're going to do is simply add those files that we just looked at, which is in my GitHub directory, looking at the video one, looking at the label. So you can see we're literally just taking the H files that we talked about before. You can see down the bottom that it's already set everything up for us, so when we add them. Okay, so now we've got the files that got created automatically, which we no longer need anymore. Okay, so we'll just check that we can just do a standard build at this point. Okay, build succeeded. So that's the first point of call. Okay, so what we need to do is when we build this, obviously at the minute it's set up for this particular scheme, which is to build for whatever my iOS device which is plugged in. We could obviously change that to build for the simulator, which we will do. Now, in the examples, there's a nice workflow using makefiles, which is really the end game when you create these bindings, obviously, to get everything automated and allow you to redo things. But I think the main thing that we need to understand is how these files are generated in the first place via the IDE, via manual actions. I think once you understand how that's been set up and how to overcome any problems based on that, the makefile makes a lot more sense and will probably be easier to create and maintain, etc, etc. So if we look at, by clicking on the top left there, look at the build settings for this project, the first thing we notice that is the architectures that this is set to build for is ARM v7 and ARM64. Obviously with the new unified API support 64-bit, I think it was out in January 2015 this year. Anything you send to Apple obviously has to support 64-bit compilation, and that's what Xcode at the moment, I think it's 6.4, has as standard. So when we build at the moment for this schema, then if I just change that to yes, then obviously the first thing we need to know is what artifacts build products is actually generating, so we know how everything fits together. Now, what I'd suggest is, just so you know where everything's created, is that by default there's a derived data location, which is basically like in .NET terminology, or I should say Visual Studio. It's like where your binary directory and your op directory gets generated, etc. per build in Xcode. Now this defaults to actually underneath your documents folder. I think for this, and maybe whatever workflow you like to use, I'd prefer it to be relative to the directory, because we're going to take some of those build artifacts and use them for creating our fat binary, which we'll then wrap a binding project around. So we've changed that to workspace relative. Going to give that a go. So when we do a build now for running, if we look at our workspace, so obviously we created it in, bear with me, projects. You can see we've got a couple which is a bit confusing, but this is the one we've created latest. This is the one I was messing around with this morning before creating this video. You can see there's a derived data directory directly underneath our top level project directory, and we can have a little look at some of the contents of these. So maximise the screen. You can see there's a build intermediates, which we're not really interested in. There's a lot of stuff in there. The main thing is our product. So you can see that there's a .a file, which is fantastic. We're gonna use a variant of that for when we're doing our binding. So we can see that we've got debug iPhone OS, so it's debug for an iOS device, which directly maps to what we've already got selected here, which is Matthew Earns iPhone 6, and what we've got debug is our default schema. I'll show you that in a moment. So if we change this to iPhone 6 simulator and do a build for running, and we go back to Finder, then we can see, okay, we've got a .a file which is used for running within the simulator. Okay, so now we're starting to see how everything fits together. Now if you do want to create a release variant for your scheme, again, this is beginner level for me, so there's probably possibly better ways of doing it. You can manage your schemes. You could go into that scheme and change it to release, or I think a bit more flexibility is just create yourself another scheme with release, go into there, and change your build configuration to release there. So now if you want to create a release variant for iOS device, we'll go with that, give that a run. And if we want to change, I've got it back to front, but you get the gist of it. I'll create the iOS device variation. Now if we look in Finder now, we can see we've got all four variations: debug for device and simulator, release for device and simulator, which is smashing. Now, okay, so one of the things we're going to need when we create our binding is a fat binary that contains all the variation architectures that we need when we deploy to simulator and device. Now, one of the things that can get you is by default, when you do a compilation, I've already created the four variations previously. The actual architectures that are built are only the active architectures, because if you look at this build active architecture only tab, it will only build what you've got specified in your schema and whatever other selections you've got. So what you really want to do is make sure that when a build is performed, it basically compiles all the architectures that you need across your .a files to save you having to worry about that at a later step. So what we notice here is that the standard architectures are ARM v7 and ARM64, and also that will be for device, but for simulator I think by default it will compile x86_64, which is a 64-bit simulator architecture, but we also need i386 in there. So what we can do is go into here, click plus, there we go, and stick i386 in. I'll also put in ARM v7 and ARM64, even though they're specified above. I don't think you need to do that, but we'll do it anyway. And then we'll click away. Now, because we've changed this to build active architecture only now, it will ensure that all the variations are compiled into the .a files that we created. Now, before we do that, we'll just go over to Finder and we'll show you how to check what architectures are compiled into each A file. So we'll do a new terminal at the folder. We'll just make that bigger. We'll do a lipo, which is the utility we'll use eventually to create a fat binary with multiple architectures, but we can do it in this way. So we'll go have a look at that, and you can see that it's already a fat file because it's got two architectures in, but it's ARM v7 and ARM64, which is the standard. So we can look at the simulator and we can see that that's only got x86_64 at the moment. So what we'll do is go back into Xcode, we'll build that, which is a simulator build for release. I'll use the keyboard shortcut to build that one. Same again. Same again. So I've rebuilt all 4 variations. So if we now go back into terminal, sorry, it's working out where I am, and we look at the simulator and the other one. Obviously we only specified the same architectures for the device, which remain the same, but you can see in the simulator we've now got i386 and x64_64, so that's good to go. Okay, so I've just tidied up the products directory, so I've just got the debug variations for device and simulator. We know by checking using the lipo command that it's got the i386 architecture installed correctly in the simulator variant, and we know that we've got ARM v7 and ARM64, which is what we need for the device variant. So what we need to do now is run a lipo command which combines the two together into a fat binary that we're going to create the binding for. So we use the lipo-create command, and we'll take the debug device variation, and then we'll also add the debug simulator variation. We then create an output file which we'll just keep the naming convention to be the same, and we'll just put unified on the end, or universal, or whatever you want to call it. It's up to yourself. Now if we look in the directory now, we can see we do a lipo on the newly created variation. I do apologise, we need the info. Then we can see, whoa, here we go, v7 36 x86_64 ARM64. So I'm assuming the x86_64 is just an i386 but for 64-bit. So basically we've got a fat binary which we can use to form the basis of the next step, which is using Objective Sharpie with an iOS Binding project to try and create our definitions and such like. So onto that. Okay, so we've got our fat binary which we've created by setting up the Xcode project and making sure we've got the right architectures, combining them all together. So the next stage in the process is to create a new solution. You can see one that I've been working on earlier, but effectively you need iOS library, you need a unified API these days, so iOS Binding project. Click next. So our project name will be TTT attributed label binding. We'll browse for that. Okay, I'll just call it Xamarin. Okay, I'll create it there. Again, you can sort out your directory structure another time. Maybe combine them all into one Git repository, which I might do later. But we can see by default we've got an API definition file which shows you some information of what you want to create, and we've got a struct and enums file which will just contain any enums and structs, surprisingly. And now the next stage, we need to go and add our fat binary which we created in there. And if you see, you can follow exactly where things are created now. You can see we've gone to the build, into products, that's where we perform the lipo command. We click open, we'll copy it to the directory. Now what you'll see is that Xamarin's created a link with file which is interesting to look at, because this then verifies what we saw with the lipo command, which is ARMv7 simulator 64, which is what we talked about with the x86_64, ARM64, and that's all done for you. Now at this stage you haven't actually got any binding which wraps around that, so this is where we need to go and get the Objective Sharpie. Now, okay, so assuming you've downloaded Sharpie and installed it correctly, first thing we need to do is have a look at information to do with what SDKs we've got installed. So we've run the Sharpie Xcode-SDKs command, and we can see that we're on 8.4 and 10.10 and 10.9 on Mac OS X. So we're obviously interested in the 8.4 stuff, building for the iOS mobile stuff. Now, what we basically need to do is tell Sharpie what we want to bind, so it can auto generate a great starting point for our binding definitions. So what we need to do is say Sharpie bind. We need to define what the output is going to be called. So in our case it's TTTB attributed label. I'll give it a namespace. Say it again. We're going to tell it which SDK, which we've already found out previously, so it's iPhone OS 8.4. And then this is the important bit, we need to give it the full path to our Xcode project which we created at the start of this chat. So what we need to do is find where we created that, which was in our root of our home folder projects. You can do this a lot neater and obviously stop so much nesting, etc. But basically we're pointing it to the H file, which is our header file, which contains all the interface or class definition or whatever the correct variation is, but it gives us our function prototypes that we can bind to. So we give that a go, off it goes. And you can see it also submits some information to Xamarin to see how people are using the tool. So when we do a little look in the directory now, we can see that we've got TTT attributed label.cs and TTT attributed label.enums.cs. So the way I would proceed with this is you can obviously call your API definition whatever you need, but for me it's a case of clear that. Let's open up these files that we've just created. You can see they're all in this products directory, just to keep it all in one place and simple. You can see that it's got a particular namespace, and again you can change the namespaces and have a play around with how it all fits together to make it more elegant. at a later point, but the main thing is to get a starting point for your binding. So paste all that in, which is the Objective Sharpie starting point, and we'll do the same with the struts and enums. I'm guessing there won't be particularly many of these in most projects. There might be a few, but take the whole thing. Okay, so we'll put it into there. Okay, so that's a starting point, so let's hit build. And we'll see some errors. So let's work through these errors now. Okay, so let's have a look at some of these errors. Okay, so with this generator in Sharpie, I think it does some slightly different stuff to previous versions, and it's mentioned here in this article to do with new Mono Touch 7. To be honest, I'm not completely up to speed with this, so I'm going to get the binding working without going down this route, assuming that it is to do with that, but that's for another time. So what I will do is pretty much take away what you'll find as a duplicate. So that is already defined down the bottom, that is already defined here. So I'm going to take away these two and leave the ones with the bulk of the information. You can see that's already defined there, and let's see where we get to with that. So we're down to 9 errors now. Now you can see that the base type of the attributed label is UI label, so it inherits from that. So we can get rid of this and this at the moment, and let's recompile that. Okay, now the same with this. Now NS range is obviously a valid type, but underscore NS range isn't. Now what I'm doing here is pretty much the result of previous trip through the binding, so it's not like I'm just doing this off the top of my head. The same with this, it's tried to look at data detector types, realise it is depreciated on a previous platform. I don't actually know what the platform is. I think it was iOS 6, might be 5, but if we look at the actual types by showing the type definitions, we can see that iOS isn't actually applicable, so we could just choose this one for now to get it to compile, and we can go back and be more specific later. We're not building this for the Mac platform anyway, and we're only going to build this via iOS 7, so for the purposes of this demonstration, I'm almost ignoring it. I suppose I could delete it, but I think it has been depreciated, that particular piece of functionality, so the proper method will actually to find out what these values are correctly, but for now, okay. Considering we are just defining an enum, I'm not sure why we would need the native namespace there. It is the attributed label. So the next stage is to actually try and add this to a project and see if the binding is working as you would expect, or whether we need to make some more changes or enhancements to this binding, and go from there. Okay, so let's create something to quickly test our new binding. So we want to choose iOS, I want to choose iPhone, and we'll just go with a single view app, and we'll call it test TTT attributed label. We'll browse. let that fire up. Very lovely. Let's have a look at our root view controller. Right then, so first thing we need to do, add a reference. Now if we look, if we browse to where binding, sorry, wrong project, the Xamarin binding, look in the bin, debug, can add that, see it's done it. You can see the other ones I've been messing around with this morning. Click OK on that. Right, we can see we've got an attributed label binding.xamarin. Okay, so we've just tapped in some code, as you can see, just creating a label, sticking some text in and adding a link. We're not actually grabbing the event handler which is actionable on the link URL for now, but we're just going to fire up this code in the simulator and see where we're up to. Okay, so we can see our text going nicely. You can't mess around with it, which if you use an implementation with UI text view, there's a lot of messing involved in trying to get that to act like a label like this. Obviously we now need to hook into the click event. Okay, so we've got the text shown on screen with the link, and now we need to hook in basically to the TT attributed label delegate so we can grab on a click event. Now I've already typed this code in ready to go. You can see that I've just created a class called myDelegate which inherits from the attributed label delegate. I've overridden the did select link with URL and I've just put in console.writeLine, but we can put a debug statement there as well, so have a little look at it. Now just need to hook into this delegate like so, and that should activate it. Now obviously if you wanted to act on multiple links, you'd pass in something different here, an actual URL or some text or whatever you need to do, so you can act on it here. But for now we're only interested in a single link, so we'll fire that up. Okay, so now when we click on look, we get the right line, we get the events, job's good. So although this works, it's a bit unwieldy having to create delegates, and it'd be a lot nicer if our binding exposed some events. So we could do something like label did select link with URL plus equals, and then creating an event handler or a lambda to hook into that, and that's a lot nicer. Obviously Xamarin exposed those kind of event handler bindings throughout the framework, so we'll have a little look at that in the next part of the video. Okay, so what we need to do is drop back into our API definition in our Xamarin Studio project, and we need to tell TTET attributed label that we want to use event handlers rather than the delegate system. So we can see that we're wrapping the attributed label delegate here just with standard export statements. So the first step you need to do is you need to go to your base type, and you basically need to say that tell it what delegates are and tell it what events you're going to use, and there's a syntax for that which is in the documentation. So paste in that we've already got, so you can put a comma there, and so we say delegates and it hooks to the weak delegate. If you notice, the weak delegate is here, and that the standard delegate is just a wrapper to the weak delegate. Again, this is just standard notation in the documentation when you read up about it.
So we set that up, and then what we need to do is go down to an actual method on the delegate, and we need to tell the binding how to basically create an event handler and some event tags for it, and we do that with the event tags attribute. Wait a second. So for example, if we go down to, which is the main one, did select link with URL, you see that it's just exported as standard there. But what we need to do is say event tags, and then we give it a name. So our event tags could be did select link with URL, which obviously matches this there. Okay, so what we can do now is we can rebuild our project. We can sort our brackets out so they actually make sense. Have a look at the error. Okay, so what happens now is, because we've started the process of turning this delegate into a series of events, we need to go through the rest of these methods and actually give them all suitable event tags. You know, basically give them a unique name. The unique name is important because if you look at some of the prototypes, you see that the names are the same. They've just got different parameters. So I've already done this in a previous example. So basically I would go through each line and give it an event tags. So I'll do that now. Okay, let's get rid of this duplicate. So we can see what I've just been talking about. If you have a look at did select link with date, what I've had to do is, beg your pardon, I was confusing things. The event tags is specified there, yeah, but we also had to change the event handler name, because obviously if we'd have kept did select link with date, we'd have had an event handler with the same thing here. So you can see we've given it a unique name there, for the event tags, and we've matched up the exported method name, or basically the event that we're going to hook into. So what we can do now is build this. You can go back to Visual Studio. You can look at our reference. You can delete it. You can add it back in. Okay. Now, what we can do now is, the whole point of changing the binding system for that is we can now say something really nice like that. So we can get rid of the use of the delegate system. We can go with that. We can get rid of the delegate, and the end result is some really nice clean code which will fire up. my console's on the other screen, but you can see that everything's working wonderfully there, and some other stuff we can do if we wanted to. Just to prove all the other events are all hooking in nicely. So that's basically an example from start to finish of taking some existing Objective-C code, hooking it all together manually using Xcode. We didn't obviously use a build script, which I'll probably do in the next video series just to show how to hook that together. We've allowed Objective Sharpie. You can see that's all working. I just held on for a long time there. Objective Sharpie to create most of the bindings for us, and being honest, I don't know all the syntax. I just basically encountered problems and I went looking in documentation to fix them. I then decided that the delegate system wasn't elegant enough, so it was time to work out how to create event handlers and events on our attributed label, and you can see the end result is basically a nice binding which we can include in our projects. And as I've said before, I'll post all the code up to GitHub so people can download the binding project, the Xcode project, and this test project, so they can follow along with that. I hope this was of help to you, and thanks very much for watching. Bye.